Hello and welcome to the third in this series of short demonstrations showing how Rational Team Concert, Rational Doors and Rational Rhapsody can help you in the process of complying to ISO 26262 for the development of safety critical automotive products. In the previous demonstrations we concentrated on how Rational Team Concert and the ISO 26262 web-based process content can help you comply to ISO 26262. Did this by providing guidance, project management and governance to the project. The subject of this demonstration goes further by covering requirements management using Rational Doors. Because the scope of requirements are very large, it also touches upon Doors' interaction with Rational Team Concert and Rational Rhapsody, showing the integration and collaboration between the various tools, explaining how they can help you to comply with ISO 26262. Before we get down to looking at Rational Doors, we need to understand how requirements fit into ISO 26262 and RTC. So what we're looking at now is the plan for the concept phase of development, and it has all the team members in it. And now what we're doing is we're looking at Susan. We can see that she has 3 tasks based around clause 3.5, the item definition. It's gathering the pre-existing information, creating the requirements hierarchy and populating that requirements hierarchy. These are all tasks related to doors. So the next stage is for her to start gathering that information and starting to carry out the work in Rational Doors. So Susan has opened up Doors, and what we're looking at here is the rich client in which we do most of the work. What we can see is a module for a hybrid SUV which has some basic requirements, but as part of those requirements we have a need for an adaptive cruise control system. This has some detail in it, but obviously not enough. So what we have is we have another module called Adaptive Cruise Control, which is linked to this set of requirements, and we can follow those links to that particular module. These give a more detailed set of requirements that map to things like states and behavior and some functionality that is required, including some of the safety stuff that's required. It's possible to link these requirements using the implemented by to a project within RTC. In this case I'm just going to quickly show you how to link to the adaptive cruise control, and we're going to create a new artifact, and it's going to be of type task. From here it gives us up the work item list that we can start to populate with things like the summary, the severity, where it needs to be filed against and who it's owned by. In this instance we're not going to create it at this time, just going to close it, but we have one that's been pre-created here. So here we have the links back to the original requirement, and then also a work item. Please do some more hazard analysis, which is connecting us to RTC. This loads up the work item, and we can see that it's being owned by Mark, who is the safety engineer, and we can see the links that have been created. In this instance the task is to carry out some safety analysis around requirement 6. The output from the task can be associated with the work item and the requirement and placed under configuration control, another key aspect of compliance to ISO 26262. Other sorts of links that can be created are relationships between various items, such as blocks or depends upon, child parent, affecting things, implementing requirements or tracking requirements. These links can also be created into Rational Quality Manager to test plans and test cases as well. Now that I've shown how requirements are linked to work items within Rational Team Concert, these requirements now need to be imported or worked upon in a tool. The way that we're going to work on these requirements is by importing them into Rational Rhapsody, which is embedded within the Eclipse client of Rational Team Concert. We can see that the requirements have been imported into Rhapsody using the requirements gateway into the system functional requirements package, and there is a view or a table view of those requirements that you can see in front of you. These provide the starting point for our item definition and doing the analysis. So here we're showing traces to our use cases and the various requirements. and ultimately they lead to doing a safety analysis, which will be detailed in the fourth of these short demonstrations, which leads to the safety goals and the safety requirements, and ultimately the identification of the ASILs and the type of requirement that has been generated. Okay, we can link all of these requirements directly to hazards or to the system elements that are going to implement them. So this is showing the system elements that are going to implement those specific requirements. This information is then exported back into doors using the Rational Requirements Gateway, of which more will be discussed in the fourth video in this series. We are now in Doors Web Access. This is a web-based view on the contents of the Doors database. As you can see, it reflects exactly the same structure as we saw in the rich client earlier on. We are now going to open up our system functional requirements, and you will see all the requirements that we saw previously. So we can see our requirements with their respective IDs. The color graduation on the side gives an indication of level of hierarchy. The links, in this instance, the outlink is going to the link in the hybrid SUV requirements, have a rich hover, so you can see information directly about that particular requirement or navigate to it. Or we can look at the work items that that particular requirement is related to. I'm not going to traverse that link at the moment. I'm next going to go into the functional safety requirements. These functional safety requirements were imported into doors directly from Rhapsody using the Rhapsody Rational Gateway. They also show all of their links internally and externally. In this instance, they are the derived links that come from Rhapsody. There is also a set of views. The initial view set that you will look for, or you will find, is a standard view, but there's also the Rational Rhapsody Gateway Export view. This is a view which is derived from the attributes that exist on the elements that have been exported, and we can start to see that we have an ASIL tag which has been exported directly back from Rhapsody. This is really important in terms of compliance to ISO 26262, whether it's requirement, the allocated subsystem, or the type of requirement. Finally, this view can be customized and tidied up, and we're now going to look at is a customized view which is really just showing the functional safety requirements along with the ASIL and the allocated subsystem. These are both requirements for ISO 26262 and can be easily captured within doors. Other views can be created which also link requirements through to test cases and test plans and the results of those test cases and test plans. In summary, this demonstration showed how requirements managed in Rational Doors can be integrated into an ISO 26262 project in Rational Team Concert and then passed into an ISO 26262 project in Rational Rhapsody. This is where the safety goals and safety requirements were derived. The safety goals and safety requirements were then passed back into doors along with links to other elements and also displaying the ASIL attributes and allocated subsystems, thus showing an integrated and collaborative environment to help you comply with ISO 26262. The fourth demonstration in this series will concentrate on one of the many ways that Rational Team Concert and Rational Rhapsody can be used to help you comply to the ISO 26262 safety lifecycle. Thank you for listening.